Hello, everybody. Thank you for joining the presentation today. Let's just wait for another couple of minutes more for more people to join. We're almost at the hour. So I guess we'll be starting the presentation now. Again, hello and welcome to our KernelCare and orcharhino presentation. My name is João Correia. I'm a tech evangelist with TuxCare. This presentation will show you some of the benefits that you get from live patching, how it works, how it's different from traditional patching, and how KernelCare, which is TuxCare's live patching offering, can integrate with your existing tools and workflow, in this case with orcharhino, to ensure that you have the fastest possible patching for your system straight from deployment. By the way, if you see a stray mouse cursor moving in front of the presentation, that's accidental, but we really can't worry too much about it right now. So live patching is often referred to as being something that's tested or very recent or something like that, but that's not really the truth of it. Live patching as we know it today, integrated with the Linux kernel, started in 2006, so that's about 17 years ago. Mr. Jeff Arnold was a student at MIT, and he was also part of a student group there, and he was the sysadmin for a server that they used in that students group. One day, that server got hacked. Upon inspection, they realized that the server had been hacked due to a vulnerability that had not been patched yet, even though there was a patch for it available for some months now. The reason why they couldn't patch it there was because it was disruptive and it would affect what people were doing on the server. So it was postponed and postponed until the server got hacked. He then proceeded to think of a solution to this, develop that solution, and I'm going to skip ahead lots of buyouts and acquisitions and all of that. But a few years after that, it got acquired by Oracle, and Red Hat also worked on it, and eventually it made its way into the Linux kernel. It has been around for quite some time now, and it's being used extensively. So why is this important still today? Why is this still a thing? Because even though we have a better way to do patching operations, we are still doing things the way that we were doing it almost 20 years ago. The issue that Jeff Arnold faced still stands. We are still doing patching operation as if we were still running monolithic servers like the ones we had before virtualization and all of that, and if we still had the same threat landscape that we had back then. That is, we are doing it too slowly and we are leaving the systems vulnerable for way, way too long. To add insult to injury, this is only being compounded by the rate at which new vulnerabilities appear, which has only been growing year over year. And this is a really important number that you should keep in mind. From 2021 to 2022, the number of vulnerabilities overall, not just on Linux, but the number of vulnerabilities grew by 22%. That's staggering. Additionally, things like ChatGPT, Bard, and stuff like that can give you code for new exploits within seconds. So now the hackers, the people trying to exploit the new vulnerabilities, they don't even have to work that hard. And they can create exploit code much faster, and they can try to hack servers much, much faster than it happened 20 years ago. On the other hand, system downtime is also one of the biggest problems. It's also one of the problems that gives IT and corporate IT in particular a very bad reputation. Oh, here goes the IT team again asking for a maintenance window, and we're going to have to stop what we're doing, and we're going to disrupt business, and accounting can process payments and all of that. And this will inevitably lead to a situation where the IT department is seen as a cost rather than a benefit for companies, and that's a big problem. So here's the thing. IT patches when it's allowed to. During maintenance windows, which are requested and approved weeks in advance, that's when people can patch. That's when you have the approval from management, that's when you have the buyout from your stakeholders and the go-ahead with your maintenance operations. Still, this causes downtime, this disrupts services, this interrupts end users, this likely ends to business revenue being lost, and nobody really is very interested in approving maintenance windows when that's the repercussion. And even with all of these downsides, even with all of these interruptions, even with all of these disruptions, we are still patching way, way too slow to properly ensure security. As an example, if you use Shodan, which is a widely available tool to scan for vulnerabilities and to scan for internet reachable IP addresses for known vulnerabilities, there are still many servers vulnerable to Log4j today, and it's almost 2 years since it was divulged and got all the press and everybody was in a panic and all of that, and still almost 2 years later, not all the systems are patched for it. So that's way past being too slow. So how can LifePatch help here? LifePatch addresses all the concerns. It causes no interruption to the server workload. The code that is running gets fixed without having to stop and restart. This saves time for IT teams that don't have to rely on maintenance windows to perform it, and it also saves time in the risk window that you leave a system exposed to a new vulnerability. The time that we're taking right now to respond to threats is orders of magnitude much more than what you get with live patching. In fact, there's absolutely no other way that you can patch as fast as with live patching. There's nothing that beats immediate. You can patch your systems immediately as the patch is available rather than weeks in the future. I know this is completely different from the way that we used to do things, but again, the difference here is staggering. Instead of having to patch 1 month from now, say to meet compliance requirements, I have a patch available now, and 5 minutes from now, all of my servers can have it applied. Nobody noticed, nothing got interrupted, no business was lost. 1 minute it was insecure, the next minute it was patched. So let's look at some of the details behind live patching. One key concept behind live patching is that, okay, you can't just simply go in and change code as it's running without any concerns. There is something called a consistency model. The consistency model basically is the state that you want the system to be in, the system or the service or the software package that you're going to live patch. It's the state that you want it to be in so that it can have some of its code replaced. For example, if you're replacing a function that has a problem and you're replacing it live with a fixed version, you want to make sure that that function doesn't have any active locks or it is not, say, requesting any memory assignments. So you want to make sure that all of that has been released before you replace the code. But this is one of the trickiest parts of the problem of applying live patches. But the thing here is that unlike traditional patching, where if something breaks, you have to fix it, with live patching, all of this complexity is hidden away during the patch creation process and is hidden away by the tool. You just deploy the patch and you let the tool worry about all of this. Most of the fixes to security problems revolve around one-liners. Say a bounce check is missed, or it's an off by 1 mistake or something like that. Most of those issues can be fixed simply by changing 1 line of code. It doesn't mean that there are no fixes that are bigger. Of course there are, we know there are, but most of the fixes fall into this category. As long as the functionate signature itself and the data structures themselves don't change, then creating the live patching is easier. It's not impossible if they do, but it makes it easier. So it might also make it faster to have the live patches available. The thing here is that, unlike traditional patching, there is no downside to live patching. One of the tasks that usually takes some time for IT teams is prioritizing what to patch. Because you have an allotted maintenance window, you have a restricted time within to perform your operations. So you have, say, 20 things that you need to patch. You have to make sure that the patches that you're deploying will fit into that time window. If you don't have the concern of causing disruption, you can simply patch everything. No more prioritization, no more wasting time tracking down what's more important, no more tracking CVEs that might get revised and have their ratings changed. Just patch all the things that come down the pipeline and it will produce a safer system overall. Another thing that happens behind the scenes before the live patches reach your system is that a live patch is a piece of compiled code that has to fit into a specific space in memory so that it doesn't override anything, it doesn't break other code that is there. So when the live patch is being created, very tiny differences in the build environment. Say you have a different compiler version, you're using different flags for your compilation process, you're using slightly different options for the kernel configuration. All of those can create a live patch that then will not fit the target location that you want to patch. So all of these concerns are addressed at the patch creation level. And again, this is heavily dependent on the building environments being the same. That's why we also do extensive testing on all of our live patches. When you have a traditional patch and you deploy it, there is a testing process that goes there before even the patch reaches your system. It has to make sure it compiles, it has to make sure it fixes the stuff that it's supposed to be fixing. And now for live patching, we also make sure that it doesn't introduce any unexpected side effects. And the traditional testing frameworks that are used in the kernel, and there is a link here for more documentation specifically on the kernel and how they test their patches, that doesn't translate nicely into live patching. There are other concerns here on the patch creation phase that are not visible on traditional patching sides. But again, as a sysadmin that is just using live patching, you don't concern yourself with nothing like this. All the complexity, and again, every process, every system has some inherent complexity. The difference with live patching is that all of that complexity is hidden away on the creation phase. So when you're a user of live patching, you don't need to worry about any of this, and you just deploy the patches like any others, with the main difference that nothing has to be interrupted. As you can see here, these are the different stages that the patch goes through. You get the traditional patch creation, then that patch gets converted into a live patch. This basically means that it needs to be compiled with the same flags, the same options, the same environment that I was referring to before. And then the tool that you're using for live patch, in our case, the KernelCare agent, will load it into kernel space, and then it gets activated. To activate the kernel, as I mentioned before, has to have that consistency model in place. So we make sure that the function is not in use, and we wait for the moment when it's not in use. And if we cannot find that moment immediately, we will wait some time and then retry. This makes sure that nothing breaks when you deploy the patches. Another difference that you get with KernelCare that you don't get with other live patching offerings is that if something is not as you would like it to be after deploying a live patch, and here I'm referring, for example, as performance hits that you get from a fix, as we have seen just recently with lots of the hardware fixes that have, the hardware bugs that have been around, the mitigations for those and the patches for those introduce lots of performance problems. So you have other mitigations in place. You have found another way to eliminate the threat vector associated with a given vulnerability, and you want to remove the patch because it is introducing a performance hit, you can. Other live patching solutions will not let you do this and will force you into a reboot. Here, I jumped one. There you go. So until now, I was just talking about patching the kernel. The kernel is the base process that is running. If you need to interrupt it to replace anything, you might as well reboot the system. That's why live patching the kernel is important. But what about user space? One thing that usually trips junior sysadmins is that when they update something like, say, OpenSSL, glibc, one of those critical libraries, and you update it through your regular package deployment tool like DNF, apt, yum, whatever you use. You do the operation, you receive the updated package, it deploys nicely, and you expect your system to be protected. The thing is, all the services that were already running before you deploy the package are still using the old version. Until you track down every single process and you restart those processes so that they get the new version, your system is still vulnerable to whatever vulnerability you were trying to fix. With live patching, you deploy the live patch for OpenSSL and it will track down the dozens of processes on your system that are using it and fix it on every single instance. That's something that until the day that you're tripped by it, you're not really aware that exists. So after deploying a live patch, you are in a situation where you have one version for a given package on disk and a different version actually running in memory. This is true of the kernel and of the others, of other live patched packages. One thing that needs to happen in order for you to get your compliance reports correct and for your vulnerability management software not to tell you that you're still running outdated software is that software needs to be aware of the live patching tool so that it produces accurate reporting. KernelCare integrates with the main vulnerability management packages out there. Stuff like Nessus, Qualys, Tenable, all of those things will have some integration with KernelCare, and you can expect a new integration to come forward if we have enough requests for it. But this way, this allows you to get accurate reporting so that you don't have false positives on your reporting saying that, oh, the system is still running kernel version so-and-so, when in reality, you're already running a much more modern version with the live patch. So what's the idea here with live patching is that we should change the status quo. We shouldn't continue to do things like we were doing it 20 years ago, just because that's how we always did it. It's no longer applicable. It's no longer even, it's not even remotely close to being enough, patching something within weeks or months. Live patching is reliable. Live patching has been around for a long time. It's a secure way to deploy your patches, and it doesn't just make maintenance windows shorter. It completely eliminates the need for maintenance windows altogether. If you're just requesting maintenance windows for patching reasons, you really need to look into live patching and forget about all of that. Another difference, and this is also a very big differentiator of ours, KernelCare Enterprise is vendor agnostic. We live patch Red Hat, we live patch Ubuntu, we live patch Debian. Most of the offerings out there will focus on their own specific distributions. And again, the majority of organizations out there are not running just one single distribution on all of their systems. So you would have to have different solutions for different distributions. With KernelCare, it's the same for all of them. This is fully transparent, this is auditable, and it fits right into your existing tool set, as Fabrice is going to show you now with orcharhino. Fabrice.
Okay, thank you. Then I will take over share. Give me a sec to actually activate it. Okay, now you should see my screen. So I'm Fabrice Mule. I've been an orcharhino consultant for a bit more than 5 years now, and I will show you how to simplify your life using orcharhino, also in combination with KernelCare. So basically, what is our goal? Our goal is to make life easier. The service means automation. There's many levels of automation which you can apply in the data center, starting with applying config management tools, for example, Ansible, SaltStack, and Puppet. Automizing your infrastructure by using container infrastructure, for example, Red Hat OpenShift, Rancher, Docker, Kubernetes. But the focus today will be on automizing the management of your servers in the data center. So the first question which arises, of course, why do we need to automate it all? So suppose now you have to install 10 new virtual machines and you do not automate, you will have to do it one by one. So installing one machine is something which can take easily something to up to several hours. So if you have to do 10 machines, it's a task which can take several days. It's quite repetitive. You have to do over and over again. And after some time, you might make a tiny mistake. And in the end, instead of having 10 identical machines, we'll have 9 identical machines and one machine with a slightly smaller hard disk. So automation does not only speed up your deployments, it increases stability, because everything is coded and will be repeated the same way as you designed it, and you achieve reproducibility. So you can create the same system at any time again once you have written the configuration. Last but not further, you can actually orchestrate your services. So when you automate your deployment, you can design, configure all your services so that when a machine comes online, it already is in target state and can be used right away. And last but not least, you can enable some self-service. So suppose you have some engineers who have their development machines, they're doing some tests and the machine breaks and we need a new one. So in normal case, we would have to open a ticket, then it can take several hours, maybe several days until the machine is provided. In the meantime, the engineer is stuck. With Orcarino, you have a self-service, so basically you can provide a certain role to the engineer. He can log on to Orcarino and redeploy a machine. And so if his machine breaks, he just goes to Orcarino, redeploys a new one, and after 15 minutes, he's back in the game again. So what do we provide by Artix of Orcarino? So basically, as you can see here, we support the automation of basically all Linux enterprise operating systems, plus also Debian, which is not technically an enterprise system, but it's fully supported by us as well. But we even can deploy Windows machines and run config management on them. So we provide consulting. So this means that basically every Orcarino project starts with a workshop where we sit together with the customer, we just see what is required, we give some recommendations, we know which plugins might be favorable, as we have much experience with other customers and know how typical Orcarino infrastructures look like. We support config management with Orcarino, namely Ansible, Puppet, and SoulStack. We have an engineering department which basically develops Orcarino. So it means we develop new plugins, for example, the snapshot plugin for VMware and for Proxmox. Further, we backport fixes from newer Foreman versions and stabilize everything and make sure that every release that we provide is actually tested and stable. Being an enterprise solution, of course, we also support. So the most basic level of support will be ticket-based. So in case a customer runs into an issue, just open the ticket, support will have a look on it and solve the issue. There are also more sophisticated levels of support, going up to 24/7 support if required. And if the customer requests, we even are able to run the infrastructure for the customer. Last but not least, we also offer trainings because every customer would like to get the best user experience out of Orcarino. And therefore, every customer can book some training, and then the consultant goes over there. Training takes typically 3 days, and then we teach them how to properly use Orcarino. So the basic idea of Orcarino is to actually map the whole lifecycle of a server, which starts with lifecycle management, with deployment, config management, and also release management. So let's go through this, several steps during the life of a server. First of all, we want to deploy it. So there are several ways to deploy a server. So the first one we're mentioning here is the so-called image-based deployment. In that case, you have a VM, a template, which will be cloned. So you get a new VM as a clone from the original one. So this is the typical deployment setting in the cloud, for example. This comes in 2 flavors. First flavor is using user data. In that case, on the template, there needs to be some cloud init configured to actually get the correct configuration. And then the server will be configured with cloud init and is up and running. There's also a second way where actually the server comes online. Some credentials are provided, and Orcarino just connects via SSH, and then actually commands are being executed to provide the host. Of course, also you can build hosts from scratch. This works with virtual machines or metal machines, and there are 2 approaches which are quite similar: network-based and bootleg-based approach. Network-based approach requires a DHCP and a DNS. If you don't have them, you can use a bootleg-based approach because network-based approach points to DHCP, and from there the DHCP points you to the provisioning templates, Kickstart in case of Red Hat-based systems, Pre-Seed in case of Debian Ubuntu, AutoYast in case of SUSE. In case you don't have DHCP or DNS, this option does not work, but instead of that, a so-called boot disk will be created where the network configuration is stored. It will be uploaded to VMware, for example, attached to the server, and then actually the server just boots from a boot disk, and from where it will be delegated for provisioning templates. So the provisioning template runs through, and our server is again up and running. An additional approach, which is favorable in case of the metal servers, is a so-called discovery-based approach. In that case, you can configure Orcarino to monitor a given subnet, and then every host which shows up in the subnet with onto Orcarino will actually boot from a so-called discovery ISO. It will collect different facts and will set up the host as so-called discovered host inside Orcarino, and from where you can just continue the deployment as you did it before in that case. We support several platforms for deployment. As I said, in the cloud, we actually support Google Cloud Platform, Microsoft Azure, and Amazon Web Services. On-premise hypervisors which we support are typically so VMware, Overt, KVM, Proxmox, and so on. So now let's actually get to the release management. So actually we want to be able to install packages, we want to patch them and so on. So you can see here that we have all the different Linux enterprise systems here. And how actually can we do that? The basic idea is there are upstream repositories, which are always latest greatest, but of course we want to have some sort of control about the versions. So we can create the repositories as a mirror on Orcarino. So we provide a repository and the URL, and we synchronize that. So the upstream repository then is available in Orcarino. And in order to get some version control, we are able to create so-called content views. So we add repositories to the content view, and we publish a version. This version then is static. It's a frozen version of your repository. So in this way, you can actually make sure that a server only gets provided given package versions. In case you need a newer version, it's not a problem. You can just publish a new version and then actually tell the server to use that one. In addition, what we provide for patching are security errata. Security errata is something which by default only comes for enterprise systems, for example, RHEL, Oracle, or SLES. We also are able to provide them for CentOS 7 for customers. Debian and Ubuntu by default do not even know the concept of errata. Therefore, we created an errata parser, which actually is parsing the update repositories of Debian and Ubuntu, and also the patching list and the mailing list of the corresponding operating systems, and are able to generate errata information and to ingest them to the Debian security repositories. In that way, we are also able to provide errata for Debian and for Ubuntu. Next step we have in our life is the configuration of the server. So the first configuration run the server runs through actually is the creation. So these are the provisioning templates which are used during host creation. Then, of course, as I said, we support as config management tools Ansible, Puppet, and SoulStack. From that, actually, we can also deliver OpenSCAP content. So SCAP contents mean that we can actually provide certain policies to servers and actually check if a server is compliant or not. So actually, we get back SCAP reports. It tells us if it's incompliant. In case if it's incompliant, it tells us what rule has been actually not met, and it even provides suggestions how to fix that. Last but not least, another way to configure our servers are so-called job templates. These can be run by simple shell scripts, so SSH, or also Ansible playbooks. So actually, we can, in case we want to run a script on several servers, we can actually just create a job template and then run it as a bulk job on several servers simultaneously. So let's tell me in the end of the first part the history of Orcarino. So Orcarino is actually based on an open source tool called Foreman using the Catalog plugin. Foreman actually is there for deployment and for config management, while the Catalog plugin is responsible that content actually can be synchronized and also subscribed and provided to the corresponding servers. So as I said, we have an engineering which actually provides in QA, which actually provides the server versions and checks that everything is stable. We provide errata information for CentOS 7, Debian, and Ubuntu, on top of the typical errata which already are there from upstream from the corresponding enterprise systems. We also, of course, provide the provisioning templates and the Orcarino clients, which are necessary to actually deploy the servers and to subscribe the servers to Orcarino. We have support starting from simple ticket-based 24/7 support up to running the system. As I said, with a consulting, which actually installs Orcarino and gives advice and consults to the customers how to get the best user experience out of that. And after consulting, we also provide the training. So basically, in an Orcarino training, it's always a consultant actually which teaches the customers how to properly use Orcarino. So basically, all of this defines the product of Orcarino. If you want to have an advanced already a look on Orcarino, there is a basic documentation which is upstream to everybody. So it's in docs, orcarino.com. And we also have webinars and event homepage on artix.de events. So this is the end of the presentation part. The next part actually would be to show you how actually Orcarino runs when using it. So let's see, there are already some questions. Preseed. Exactly, yeah. I see here that preseed is supposedly dead since Ubuntu 20. That's right. So I slipped that one exactly. Starting with Ubuntu 20 or 4.3 and 22, the typical installation method is auto install, which is sort of cloud init. So yes, when deploying Ubuntu 22, we provide cloud init templates, and actually everything is provided with auto install and no longer with pre-seed. That's right. So actually Ubuntu 22 started a different mechanism, which also is supported by orcharhino. Then with the question if deployment on Kubernetes with KubeVirt is supported, as far as I know, I'm not aware of that. I'm not quite sure, but I'm not aware of that. And then with the question how long installation for Orcharhino takes. So it depends. So the basic installation when setting up a system for a new customer is something which takes typically a day, but it depends on the complexity of the infrastructure. So if a customer has many subnets, possibly at several locations, data centers, proxies and so on, this is something which can take much longer. So typical installation, we would say, is something like 5 days, but normally we, in the initial workshop, we collect the information and give an estimate how things take. Okay, I will address the next questions at the end of the demo, because otherwise we get stuck too much in here. Also, the question of integration between KernelCare and Orcharhino is not clear. Yeah, I will show you now in the demo in the endpoint. So let's first of all show you how easy it's actually to deploy a server on Orcharhino. As you can see here, this is the host page of our Orcharhino, where you can see that we are already running several different operating systems, starting with Alma, CentOS, Debian, Oracle, Red Hat. So basically all the systems I mentioned before. So actually now I can just click here on create host. And you can see with only a couple of clicks, I can just deploy a server. So I select a host group. Let's select Alma Linux 8. So in this host groups, actually, we can already predefine all the parameters which are required for the server to be deployed. And you can see here now everything is pre-filled out. And now if I click on submit, you can see that actually on vSphere, the server is being created. And the server now is running in the deployment. Let's give a sec that actually it gets detached and shows us the actual status. So we see here now this server is running. Status okay, build is pending installation. We see additional information like build duration, which was running it, domain, IP address, salt master, and so on. Now, actually, let's have a look on a server which actually already is online to see what kind of information we got there. So let's go back and have a look on the running Alma server. As you can see, the status of this Alma server is red. It's an error status. Why is that? So we can see here, the status here is just a summary of all the statuses below here. And we can see that this actually comes from errata status. So this means the server has errata open and needs to be patched. This is something which we do on purpose on our demo system, because so we can actually demonstrate how you can patch the server. It's very difficult to patch a server which already is up to date. So as you see here, all the different information, build is installed, configuration has no changes. So actually this refers to the status of the last configuration manager, and run no changes says the last run didn't change anything, but everything is fine. In case something went wrong, it would say, show an error. In case something would have been changed, everything is fine, it would say active. But it says no changes is fine, because we have regularly running Puppet, Ansible, SoulStack, and after it ran once, everything already is in target state and does not need to be rerun again. Actually, we can have a look on the reports of the corresponding server, and you see here that regularly there are some runs going through. So you see here we have every half hour Puppet which is running, getting a report. We have SoulStack, which was running once an hour. We see that we did a change to Puppet something like 5 hours ago. And if we go to initial deployment of a server, we also see that we got an initial Ansible report when the server was deployed. So now actually let's have a look on the content part, because release management, patching, and so on is something which is very interesting with Orcharhino. So for that, we can click actually on content. Now we get just a general overview. We already see we have 9 open security issues. We see the lifecycle of a server. So this is a testing server, which is connected to the content view, so-called content view composite Alma Linux 8. So basically this defines what kind of repositories are provided for a corresponding server. So if we go here to subscriptions, we actually see what products have been subscribed for the server. If we go to repository sets, we see what repositories are active on the server. If we go now here to packages installed, we get a list of all the packages in the versions which are installed on the corresponding server. In case we want to know what updates are available, we can go here to packages and applicable. And then we see a list of all packages which are installed on our kernel, but for which there is an update available. So let's wait a sec until the page has loaded. Taking a bit because apparently the server is a bit more outdated. Okay, in the meanwhile, while it's loading, okay, now it's there. You can see here we have, for example, curl. So curl is installed, but there is a newer version and so on. And actually now we could just click on update all packages. Then via remote execution, all the packages would be upgraded. We also can just upgrade single packages by checking them. If we go here to actions, actually, we have more options. So you see we have package install, update, and remove. So actually we can just type in a package name, install, update, or remove it. Next step we want to have a look is we want to patch our server. So we want to see if there are security errata available and so on. So you see here's a list of errata, which actually tells us that there are some issues which are open. So let's, for example, now have a look on the kernel errata right here. So if you click here on the name, we see here the type, we see a title, when has been issued, a description, and the solution. So description here on Red Hat, what is wrong with the original ones, what has to be fixed. And actually we get here a list of the package versions which are affected and to which version. So this is the minimum version to which the corresponding package needs to be upgraded to actually close the issue. So let's actually show you how such a patch can be applied. So this is something which is very, very complicated. We just check the one corresponding erratum. We click on apply selected, and then a remote execution will be triggered on the server. If we click here on preview templates, we can actually see what is running. So this is just a simple yum action doing a yum minimal update, providing the advisory. And this is here just the errata ID, which we are applying to the server. In case that you are curious and want to see what actually happens on the server, we can actually have a look here. We click on the server name, and we see now here the yum action is running. So the server is busy quiet now. So I suggest just that we just keep it, let it running, and we have a look on the other parts. So now there was a question on the integration of KernelCare. So actually you can see here that on our Carino, we have installed the KernelCare plugin. So let's have a look on one server where we actually provided the possibility to apply KernelCare. So let's go back to our all hosts page. And we see here, we have here our KernelCare demo server. So first of all, what we want to do is we want to register this host with, at first we need to install the KernelCare package. So let's do that. We just schedule a remote job. So this means we just trigger remote execution. We look for the option live patching, Ansible default, and we install the KernelCare package. Now an Ansible playbook or an Ansible role just runs over the server and installs actually the KernelCare package. So let's wait a sec that actually the package is installed. Yeah, take some time. In the meanwhile, okay, now you see the Ansible playbook started running. So while this one is running, maybe we can have a look back on our server, which was running with the standard erratum. Still running. Patching takes time. That's why we want to speed things up. He actually is installing the package. So we have to wait a few seconds until one server has been patched, and on the other, the package actually has been installed. Come on, don't let me down. Okay, right. So we see here, access status is fine. Package has been installed. So once the package is here, we can register the server with KernelCare. So we go back to remote execution. We have now a look on the live patching script template, and actually we want to register the host. So we just go here. We register the host, shouldn't take too much time. It's successful. Now this host is registered with KernelCare. Now actually, let's have a look on the kernel version which is running on the server. So let's go back here to our live patching and see the kernel version, which is available at this moment. So we click here on submit. Now we have a job which actually connects via remote execution to corresponding server and checks the kernel version which is there. So we see here now at the moment, the installed kernel is just this one here. And as we freshly installed KernelCare, the kernel has not been patched yet. It's still the same version. Now let's actually live patch the kernel using the KernelCare plugin. So I go back here to rerun. And now I have here the job update kernel. And I trigger that one. So now this host is being patched. Let's wait that it returns the exit status. So you see here it's still busy. While this one, okay. Now we see here patch level 10 applied. Effective kernel version is this one. Exit status 0. Kernel is safe. So now let's actually check again the kernel version which is being reported. So now we can just have a look on kernel version. We click here on submit. So let's have a look. And we see here now that the installed kernel version, which is on the hard disk, is the 18.04.477.10.1 and so on. But the patched version, the one which actually now is active, is the 21. So we patched our kernel and the kernel is running. And more important, if we now go back to our host page, let's see the major difference. So we see here, it just says that the erratum is still applicable, but still is fine. Now let's have a look on the difference between the host which has been live patched and the host which just has been patched ordinarily. So we can go back here, have a look on this host. And we see here, the ordinarily patched server says we need to reboot the server because we did a standard patch, while the KernelCare patched server is fine and does not need to be rebooted. Basically, I'm pretty much at the end of the demo, so let's have a look on additional questions which might have been.
Fabrice,
yes?
Let me just add something there.
Sure.
If you've ever done sysadmin job, and if you've ever run a maintenance operation, that thing there that Fabrice just showed you about the kernel running a new version and no reboot being required, that would have been a godsend during those maintenance operations. It would sure have saved me countless hours of work.
Okay. There was the question for a roadmap available. I'm not sure a new roadmap for a new release. I'm not sure to what that actually is referring. And the last question here is about deploying Nutanix. There is no plugin on orcharhino yet to deploy Nutanix. Actually, you can connect Nutanix server afterwards, but there is no plugin to deploy it right away from here. So I guess we are still open for additional questions.
We will have the recording of the presentation available later. If you also have questions afterwards and you want to add them and you want to ask them and you don't make it today, feel free to reach out to our emails or directly to the team. We will answer your questions after the presentation as well.
So one question which still came in was how live patches are regarded by distro vendor support. Are they viewed supported the same way as the kernel update? I guess that's a question mainly to you.
Yeah, I can cover that. Live patching the kernel does not touch the files on disk. So if you want to contact your vendor for some issue regarding your system, you can simply disable KernelCare at that point, and it will be exactly as it was before. There will be no change to what's on disk, so there is no difference. Yes, Oracle Linux is one of the supported distributions.
Okay, I think we're good so far, so
Yep.
there are no more imminent questions here.
I think we're good as well. Thank you everybody for joining. Feel free to reach out if you have any further questions. And again, appreciate you guys being here and watching the presentation. Thank you, Fabrice, as well. It was a pleasure.
Thank you as well. It was a pleasure
Bye.
also for me. Okay, bye.